Hey guys, welcome to Growth and Decay. It's going to be a continuation of exponential functions. We're just going to look at specific examples when we have growth versus when we have decay. So growth is just going to be anything that is increasing in value over time. So this would be an example of growth. Decay is going to be decreasing in value over time. So this one is, see how it's going down over time? So yeah, that's growth and decay for you in a nutshell. So let's take a look at some real world examples. So an equation for exponential growth says the form of the exponential equations is y equals a 1 plus r to the t. Now on your notes, you guys have like a clear picture of this. I went ahead, it didn't print off on my paper, so I wrote it down here for you. So I've got y equals a times 1 plus r to the t power. And you're probably like, what the heck is this? Well, let's just break it down nice and easy. So a is going to be your initial amount. R is going to be your rate of change. So this is typically like a percent or a decimal. And t is going to be time. Time typically dealt in years, but it doesn't have to be. And then y here is going to be your final amount. So let's take a look at an actual example. So it says here, for example 1, the prize for a radio contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. Okay, so for the next day. So I've got a $100 gift card and 2.5%. Let's see what we can do. So it says write an equation to represent the amount of the gift card in dollars after t numbers of days with no winners. So numbers of days is going to be our t. So we're going to use this right here to try and write an equation. So I don't know what our end amount is going to be, so I'm just going to put y for now. How much did I start off with? Well, I started off with this $100 gift card, right? So I'm going to put 100 here. 1 plus, what's my rate? Well, my rate is this percentage right here. It's 2.5%. And you always want to write this number as a decimal. So let's do 2.5% as a decimal. It's going to be, we'll move it over 1, 2. Fill in a 0, so this would be 0.025. So that's it as a decimal. So I'm going to put in here 0.025, and then it says for t number of days. So I'm just going to put t here because I don't know how much time we want. So that's my equation. I can figure out at any number of days what the value of this contest is going to be. After 1 day, after 2 days, 20 days, however many days, I can use that to figure it out. So how much will the gift card be worth if no one wins after 10 days? So this is going to be our time. So I'm going to plug in, I'll have y equals 100, 1 plus 0.025, I'm going to plug in 10. And then all you got to do is plug this into a calculator. So this will be 100, 1.025 to the 10 power, and I think I got around $128. So this was 128.00, so it's around 128.00. So after 10 days, this is around how much that contest is going to be worth. All right, let's take a look at something called compound interest. It's just interest earned or paid on both the initial investment and the previously earned interest. It is an application of exponential growth. We use a similar looking equation to denote compound interest here. A compound interest is just earning interest on your interest. That's all it is. So you're just earning, it's like interestception. So you guys have, again, a nice picture here. Mine kind of got cut out, but we've got P is principal. Your current amount, or that's your end amount, I guess, is going to be A. Same thing as y here. They're no different. Except this time we're gonna have since it's compounded, we're gonna have this divided by n, and we're gonna have an n in the exponent. So n is just the number of times the interest is compounded in a year. So we have to factor that in. So instead of it being this t just being daily or yearly, now we have this compounded part that we gotta throw in. It's not bad, I promise. So I think it'll make more sense once you see an example. So let's look at this example too. So it says, Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will there be in the account after 10 years? So if you flip to the back, we've got some questions here. It says, what is your principal? And this should say principal. So what is your principal? Well, if you look here, your principal is your starting amount. Right here, principal, let's write that. Is your starting amount. So it's your starting amount. How much did we start with? Well, we started with 14,000. So I can put 14,000 here. What is your interest rate? Well, let's see. What is my interest rate? What, 6%? 6%? I'll put that here. Or as a decimal, it would be 0.06. What is your time frame? Okay, what is my time frame? Well, I know it's compounded monthly, so let's keep that in the back of our minds. And we want to know after 10 years, right? So let's say compounded monthly. And we want to know after 10 years. Okay, so let's put it all together. Write and solve the equation. Let's rewrite the equation. It was A equal to P1 plus R over N to the NT. All right, what's my principal? My principal is 14,000. So I can say 14,000. 1 plus, what's my interest rate? Well, that's the 6% or 0.06. So I can say 0.06 over N. What was N again? Well, if we come back to our equation here, N is the number of times interest is compounded in a year. Well, we said we wanted it compounded monthly. So how many months are in a year? Well, 12 months. So for N, N will equal 12. So then I can come back over here. I'm just going to plug in 12 down here. And this will be to the N times T. So this will be 12 times 10 years. And that was the hardest part. Now you just got to plug it into a calculator. So 14,000, this would be I think I got 1.005. And then this is to the 120 power. So then this would be 14,000 times 1.8193967, and you get something around, this just means around or approximate, you get something around 25,471 655. Yeah, if you can get a 6% interest rate, that's really good. So in 10 years, you made $11,000 doing nothing. So yeah. All right, I'm gonna pause it here. We'll do the next two on the next video.